Okay, so let's get started. We're going to be taking a look at setting up and working with blow-off valve based boost control. This is going to allow us to control the boost level and the power output out of a supercharged engine or any turbocharged application. Now, the advantages to using a blow-off valve for boost control on a supercharged engine is that the pulley ratio is fixed on a supercharger, meaning we're going to be generating whatever that pulley ratio is set up for in terms of boost and power. In lower gears or in traction limited situations, we may not want to run all of the boost and all of the power. By utilizing a blow-off valve and having that open up when we're in when positive manifold pressure and boost, we can actually dump some of that boost pressure out and essentially regulate our power output out of our engine to allow us to gain traction. So using a blow-off valve is a very good means of power management on a supercharged engine. If we're talking about a turbocharged engine, specifically a drag race engine, when we're in first gear, you may be traction limited. Second gear and on, you may have full traction, be able to put all of the boost and power down. When we utilize a blow-off valve based boost control, let's say, and stage it for the first couple seconds of a run in first gear, we'll find that we're able to then dump the power and boost so that we can gain traction in the first gear, lower gear. And then when we click over to the gear that gains us traction, let's say it's second gear, we can close the blow-off valve, and then it'll allow the boost leak to stop and have instantaneous boost pressure and flow and make all the power output out of our engine. That can really help us get our 330 and 1/8 mile times down by accelerating really hard in second and third gear. So this is something that I use on drag race engines. I also set up and use this on street vehicles that are supercharged. I typically don't use the blow-off valve based boost control when we're talking about a turbocharged engine if it's a street car, because there's really no advantage to winding up that compressor speed, having the controlled boost leak using this type of control. It's really used for a drag race vehicle, and it is very, very effective. For example, I was working with a client's drag race S2000, and off the line, we couldn't handle more than about 15 to 20 pounds of boost. But in second gear, we could handle around 60 pounds of boost. So as soon as we clicked from first to second gear, we could put all the power down essentially that we're able to build. By utilizing the blow-off valve based boost control, I was able to dump the excess pressure out and not lose traction, but still wind that compressor speed up and be able to click second gear, shut that blow-off valve, and essentially have all of that boost and power available. And it really changed our ET going down the drag strip. We shaved about 3/4 of a second off our time by experimenting with it, so it is extremely effective. Let's jump in and take a look at setting and configuring this. It's really, really easy to program and work with a blow-off valve based boost control. Let's go and take a look at this real quick. So what we're gonna find is we move from our tuning window here, and we're gonna move over here into setup. Now under setup, we're gonna jump in here to all calibrate. And under all calibrate, we're gonna use the auxiliary output option to program this feature. This allows us a generic approach controlling an output to do a desired task. So in this case, to control the boost solenoid to be able to keep that blow-off valve open or shut it depending on the conditions we wanna run our engine in. So let's go here into output and let's talk about a few things. First thing is we need to assign the output resource or the pin where we have wired our boost solenoid. Now I'm gonna have coming up on screen just a little basic picture that's going to show how the boost control solenoid is going to be set up, and then we can talk about our pin resource allocation. So when we're looking at our picture here, we're going to find that we have an intake manifold, a blow-off valve, and a boost solenoid. And this boost solenoid is a 3-port MAC solenoid, extremely common, very, very cheap. So this is my solenoid of choice when I'm working with doing any kind of type of control of the boost solenoid. Now looking at the solenoid itself, we're going to note that it has 3 ports and each port is numbered. There's a port 1, 2, and 3. In this orientation, we're going to have the manifold pressure referenced going into port 3 on the boost solenoid, and then port 2 is going to be going to the actual blow-off valve. And what this is going to do when the solenoid is not energized, it's in the normally open state with this port configuration. Meaning, if I don't energize the boost solenoid, we're going to have manifold pressure essentially flowing in port 2, flowing in port 3, I should say, flowing out port 2, and going right to the blow-off valve. This will operate the blow-off valve as it normally would. So in positive manifold pressure, it'll have a pressure reference. The blow-off valve seals shut so we don't have a boost leak. And then when we lift throttle, we find that we're in vacuum. All of a sudden the blow-off valve will open up and it's gonna dump the excess pressure and not go into compressor surge. And that's kind of the purpose of having the blow-off valve. So when we are energizing the solenoid in this configuration, we're starting to bleed off the pressure reference to the blow-off valve, which naturally under boost will push the valve open and have a controlled vacuum leak. So in this orientation, controlling the solenoid from our Motec, we are able to vary how much that valve is actually opening and then also how much excess pressure and flow we're dumping out, which can really drastically reduce the power output out of our engine. For example, in that drag S2000 I was mentioning, I was able to achieve about 60 pounds of boost if I had the boost control routine full tilt, so everything was essentially wastegates were shut. We were building about 60 to 65 pounds of boost. When I opened the blow-off valve, I could drop the boost down to about 15 to 20 PSI, and I would go from about 1300 wheel on my mainline dyno to about 600 wheel. So a huge difference by just utilizing.
Thanks for checking out our teaser clip. If you want to see the rest of this video and more than 500 hours of current EFI training we have to offer, make sure you click right here. If you want to go and check out more teaser clips from this training course, click here, and you don't want to miss any of the videos we're going to be releasing on this channel, so make sure you subscribe and click here. Thanks for watching, and I'll see you guys later.